All right, so we're going to be looking at the third kind of log problems, and it's the kind where you have more than one log on one side of the equation. And anytime you have more than one log on one side of the equation and a simple move to the other side of the equation won't solve our problem in here because we have a 3 over here. So the only thing we're going to be able to do is use the log properties to condense these two logs down into one log, and that's what they've used right here. They've condensed. They put log base 2 of x plus log base 2 of x plus 2. They've combined that into one log by multiplying those two things right there. Then they begin the process. Now that we have it condensed, now it's that problem that we had at the beginning where you just have one log on one side and you have to rewrite them as exponentials so that you can divide out all of these things right here. Whoops. So you can divide out this 2 log 2 and then it becomes just a problem where you've got x times x plus 2 is equal to 8. Well, that goes back to, that makes that a quadratic, and so in order to solve a quadratic, they factor it and they get 2 answers. They do check those 2 answers for extraneous solutions like we talked about in one of the previous videos. I do want to remind you right here that the reason that you can't do this is because we can't have a negative number right here when we're doing a log. This number cannot be negative. Why? Well, if you rewrite this problem right here and you rewrite it in exponential form, that means that 2 is the base. We don't know what the exponent is. That's the question mark, and that's going to be equal to a negative 4. Well, there is no way that we can turn a positive 2 into a negative 4 by raising it to any kind of power. Because if we raise it to a positive number, then and a number bigger than 1, then 2 is just going to be, multiplied times itself that many times. There's no way to make it become a negative 4. If we raise 2 to a fraction, then that just makes the answer become a fraction, but it doesn't make it become negative. And if we raise this to a negative number, like 2 raised to the negative 4, then that just becomes 1 over 2 to the 4th power. So even raising it to a negative exponent, it still becomes just a fraction. So there is no way to take a positive 2, raise it to any power to make it become a negative number. So we don't take the logs of negative numbers. So that's why we know that that's an extraneous solution. All right, so step number 1 on part A right here is to condense this log base 4 of x plus 6 minus log base 4 of x is equal to 2. So we have a minus sign. That's the quotient property. So that means this becomes one log, and it's going to be x plus 6 on top and x on bottom. Okay, and that's going to be equal to 2. So that was using the quotient property. So that was step number 1. And then step number 2 is going to be, we now just have a problem that has one log. So what do? We make both sides, have a base of 4. So this becomes it becomes 4 raised to the log base 4 of x plus 6 over 6 equal to 4 raised to the 2nd power. So those simplify out, leaving you x plus 6 over x is equal to 4 squared, which is 16. Okay, we just are trying to get the x by itself. So this says x plus 6 divided by x. The opposite of division is multiplication. So I'm going to multiply both sides by 6. These divide out, leaving me x plus 6 equals 16x. And now it's a matter of subtracting x from both sides. 6 is equal to 15x. Divide both sides by 15. And we get x is equal to 16 over 15, which I'm sure simplifies down to a nice pretty decimal. You could leave it 6/15 or reduce it. Of course, 6/15 reduces down to 2/5. So you could reduce it down, or you could change it to 0.4, whatever the directions tell you to do. And that is problem A worked out. We do need to check and see it, make sure that's extraneous. 0.4, if you plug 0.4 right there, you maintain a positive number. You plug in 0.4 right there, it's a positive number, so you don't have to worry about it creating an or that being an extraneous solution. It works. Go ahead and pause the video and see if you can do either one of these. This one down here, part C, is going to require you to do a quadratic, so it's going to be kind of like this one when you start solving that quadratic. Pause the video and I will get these two worked and share my answer with you after you unpause it. Okay, you're back checking your work with my work. I combined the natural logs. The plus sign told me to multiply. I made both of each side of the equation become the exponent to the base e, and the reason I chose the base e is because natural log has a base e. They canceled out. Then I had this problem to solve. Remember, e is a number just like pi, so it's an irrational number. I could have rounded off way up here, but I wanted to wait until the very end. Subtracted 10 from both sides, divided 10 from both sides, and then I typed this into my calculator, and I got a value of negative 2.611. Be careful, because people jump to a wrong conclusion over here. They think, oh, negative numbers are always going to be extraneous. That is not true. If you take this value up here, negative 2.611, and you plug it in right here, you have 2 times negative 0.2611 and then plus 2. When you enter that value into the calculator, what you end up with, this all simplifies down to 1.47. That is okay. You can take the natural log of a positive number. So just because we got a negative x value does not mean when you evaluate this algebra expression right here at that negative x value that the value of that expression will be negative. So that's what's important, that you can't have a negative expression in here once it's been evaluated. So this answer is actually a-okay. I worked out C and combined. There's a plus sign, so that means multiply. Raise them, change it to an exponential problem by putting the base 2 down there. Distributed here, got this, subtracted 8 from both sides, factor out a GCF of 2. That made it easier to factor. But this time, when I plug in a negative 1, plug in 4, you get 8 right here, you get 1 right here. That's okay. But right here, when you plug in negative 1, that'll give you a value of negative 2, and that'll give you a value of negative 4, and you can't take the log of negative 2 or take the log of negative 4. So this one is extraneous. Okay, hope that helps.